Hello, welcome to another installment of Seminole High School Geometry Online. This is Mr. Tipton filling in for Coach Walker today. I'm going to be taking you through Geometry Chapter 1.2 from the new Carnegie book. What we're really going to learn today is we're looking to be able to find the distance. Another word for distance is length. You may see it written that way. We want to be able to find the distance between 2 points, give a measurement to that. Today we're going to be using the Pythagorean theorem. We're also going to be using the distance formula. Both of these are going to pretty much be able to give us the same thing, but typically you see the distance formula used when there's a line segment in a coordinate, and the Pythagorean theorem is only really used when you have right triangles. We're also going to learn how to translate a line segment. This other stuff here, the duplication of a line segment and the construction of one, we'll show you how to do that in class. We're not going to go through that on the video here. So let's look at this first slide. Pythagorean theorem is something that you should probably be familiar with. I'm sure you've seen it before. The formula for it is a squared plus b squared equals c squared. Over here we have a right triangle. Now most of the time right triangles, you'll notice, will have a little box there in the corner showing that it's a 90-degree angle. The real important thing here is this. C must always be your longest side. It's always across from the right angle. If you look, that right angle will point to your hypotenuse. It has to be your longest side. A and B really don't matter, but as a personal preference, I like to make the side that appears to be the shortest A, and the medium one I like to call B. The hypotenuse is always C. Let's look at an example here. So here we have a right triangle. I know that because there's a box here in the corner telling me that it's a right triangle. And like I said, we're going to set up our Pythagorean theorem here. I would say that A this appears to be the shortest side. So I would call this side A. It's labeled with a length of 9. The next side I would call B, which is marked as 12 units long. C over here, we don't know what it is. But it is going to be our hypotenuse. It's our longest side. Hopefully you can see that from just looking at the picture. Well, now let's go ahead and write in some values here. So now I've written my Pythagorean theorem over here. If you look, we have a squared, 9 takes the place of a, so we have 9 squared plus b squared, 12 takes the place of b, equals c squared, which is our hypotenuse. I don't know what it is, so I'm just going to leave it c squared. The next part we get to is actually squaring the numbers. This is 9 squared. Don't make a mistake and put 18. We're not doing 9 times 2. It's 9 squared, which means 9 times 9. The answer is really 81. Plus 12 squared. 12 times 12 is 144. Equals c squared, which I don't know what that is yet, so I'm just going to leave it c squared. 81 plus 144, did it in my calculator, is 225, equals c squared. Notice, though, that c is not by itself yet, so we've got to get rid of that square. Well, the opposite of squaring something is to square root it. A lot of kids will divide by 2 to get rid of that. That's not a times 2. That's a square. So we have to square root 225 to give us our answer. The square root of 225 is 15. So 15 is the length of C. Let's see if that makes sense. The hypotenuse has to be our longest side. This is the hypotenuse. 15 is larger than 12 and 9, so I feel pretty confident in that answer. Let's look at the next problem. This one's a little bit different. So in this case, we actually have the hypotenuse. Our longest side is already marked. The length of our longest side, our hypotenuse, is 10. We're not looking for c squared this time. A lot of times, people will want to just do the 2 numbers they have as a and b and always find c. In this case, we have c, so be careful. A is what we don't know. We don't know what this side is. So I'm just going to leave it a squared. Plus b is, in this case, 8. So I want to do 8 squared. Equals c squared, which in this case, the hypotenuse, the one that's important, the longest side, is 10. So 10 squared. We're not trying to find c this time. Now we just do our math. I don't know what a squared is, so I just leave it a squared. I do know what 8 squared is. 8 times 8 is 64. And I do know what 10 squared is. It's 100. Notice the difference here, though. 64 and 100 are not on the same side of the equal sign. So we must remove this stuff that's with a over here. We've got to get rid of the plus 64. We've got to get rid of the square. So first, I get rid of the plus 64. I subtract 64 from both sides. This leaves me, well, that's eliminated. 100 minus 64 is going to leave me with a squared equals 36. You should know what the square root of 36 is. Remember, we're going to square root this number. The square root of 36 is 6. So in this case, our shortest side, our a, ended up equaling 6. So that's the Pythagorean theorem. Just remember, the hypotenuse must always be your c. Now we get to the distance formula. This is the formula. It's boring, I know. x2 minus x1 squared plus y2 minus y1 squared. The thing to remember here that people forget is we're subtracting x2 minus x1. A lot of times people just want to plug a point in there and say x1 minus y1. No, we actually have to label our points and then pick out x2 and x1 squared plus y2 and y1. So this formula is pretty boring, to be honest with you, and it's kind of hard to work with. I'm going to show you hopefully an easier way we can use this. So now we want to find the length of AB and CD. Well, they just told me length, distance formula. I'm probably going to use the distance formula. However, in this case, AB is right there on a straight line. So why go through the problem of plugging in the distance formula? If you can count, you can find the length of AB. So in this case, I want to just start at A and count how many units I have to move to B because they're on that line. So I go from A, 1, 2, 3, 4, 5. The length of AB is 5 units. I don't have to do any crazy math. If you can count, you can find that because it's on the line. Some people, though, start with A and say 1, 2. No. Wherever we start, the first movement is 1, then 2, then 3. The length of AB is 5. Let's find CD. We start at C. We count 1, 2, 3, 4, 5, 6 units over. So those are easy. Do not use the distance formula on those. It'll waste your time. Let's look down, though, at one that we have to use the distance formula on. Here in this case, this is not on a straight line. It is a straight line, but I'm saying it's not on an X line or a Y line going up or straight down. So we must use the distance formula. So here's our distance formula. x2 minus x1 squared plus y2 minus y1 squared. And then at the end, we square root it. That's what that means, that symbol right there. But first, we have to find out where B and A are located at. So I start at the origin. B is located at 1, 2, 1, 2. So I would name B 2, 2. That's where B is actually located at. A is located at, I go over from the origin, 1, 2, 3, 4, 5, 6, 7, 8, and I go up 1, 2, 3, 4, 5, 6. So A is going to be located at 8, 6. X is your first number. We went over 2, so we put 2 for X. We went up 2, so we put 2 for Y. They're both positive. X and Y. Now we just need to give them a name. Well, since this was the first point I counted, I'm going to call this X sub 1, Y sub 1. It means nothing mathematically other than this was my first point. So if that's my first point, this is my second point. So I'm going to call this X2, Y2. The only reason I'm writing that out is because now it's going to make the distance formula easy. So I want to plug these numbers in. So for x2, I look over here. x2 is 8 minus x1. Don't put 6. Look, x1's down here. It's 2. Squared plus, we have y2, which is 6, minus y1, which is 2. We're squaring that. Now we just do the math. I'm not going to rewrite the square root sign. I'm just going to do that at the end. But I do the parentheses first. Order of operations. 8 minus 2 is 6 squared plus 6 minus 2 is 4 squared. Now I square these. 6 times 6 is 36. plus 4 times 4 is 16. Add those together, and I get my answer of 52. If you forget to do this last part, you'll make a mistake. You must square root your final number. Do you really think this is going to be 52 units long if that's 2 units and that's 8 units and 6 units? No, that's not 52 units long. So we must square root this. I put that into my calculator, and the distance ends up being 7.21 rounded to the nearest hundredth. That's my answer. That's the length of segment AB. So now let's look at this problem. Again, this is the same exact line segment. B is located at 2, 2. A is located at 8, 6. But I'm going to show you how to solve this with the Pythagorean theorem. Watch. I'm going to create this line segment into a triangle, with the line segment being the hypotenuse. So I'm going to start at A and go down to where B is, and then I'm going to go from B and over to where A is. And look, a right triangle has been created. I'm going to now count the length from A to that point I just made. It is 1, 2, 3, 4. Now I'm going to count the length from B to the point I made to get that intersection. It is 1, 2, 3, 4, 5, 6. Now we have a right triangle where all we are looking for is the hypotenuse. Here comes Pythagorean theorem. Here's the Pythagorean theorem. A squared plus B squared equals C squared. A is going to be my shortest side, 4, plus B, which is my medium side, 6 squared. And then the hypotenuse is always your longest side, the one that's across from the right angle, so C squared is going to just stay C squared, because I don't know it yet. Now look at this. Here's my formula. Let's go back to the last part. If we look down here, there's where we're at. 6 squared plus 4 squared. We just skipped all this stuff of naming points and everything. Makes life so much easier. We're already almost finished with this problem by using the Pythagorean theorem. Again, 4 squared is 16. 6 squared, 36, equals C squared. We add those two together, we get 52 again. And then we just take the square root to get our answer, 7.21. Much, much, much easier to solve. Over here I've drawn another line segment. We'll call it CD. Let's see if you can find the length of CD using the Pythagorean theorem. So go ahead and try this on your own, and then I'll show you my answer. You should draw in the sides of the triangles. So we have from C over to where D is, we have from D up to where C is. Creates a right triangle. So go ahead, pause this for a minute, try to do the work, and then I'll show you my answer. And here's my work. So we went over from C to where D is. We went over 2. We went down 5, so that length is 2. That's 5. There's my A. There's my B. 2 squared is 4. 5 squared is 25. Add them together, we get 29. We're finding the hypotenuse. Take the square root of 29, 5.39. Very simple. The last thing we're doing today is translations. This should be pretty easy to do. We're going to translate AB 8 units to the left. So we start here. We're just going left. So start at A, count over 8 units to the left. 1, 2, 3, 4, 5, 6, 7, 8. There's where our new A is. We call that A, justification, a little comma up there. And then we have 1, 2, 3, 4, 5, 6, 7, 8. There's where our new B is. And we give that a little comma up there. So the translation of AB left 8 units is going to look like that. Now let's think about if we had translated AB 3 units to the right. We would go 1, 2, 3. There's our new A. And then we would go 1, 2, 3. There's our new B. That's the translation there of AB 3 units to the right. We could do the same thing for AB going down. So we come back here. AB going down 6 units. We go, A would be from here to 1, 2, 3, 4, 5, 6. Actually, A is going to be where B is at. So our new A is there. And from B, we go down 6 units. 1, 2, 3, 4, 5, 6. There's where our new B is at. And that's our translation. We translated it down 6 units. Sometimes we may have situations like this where we want to go up 2 and right 5. So here's A. From A, I want to go up 1, 2, and right 1, 2, 3, 4, 5. There's where A is going to be located after the translation. For B, we go up 1, 2, over 1, 2, 3, 4, 5. There's where our new B is going to be located at. And we can make these into a line. Boom, line segment, I should say. All right, that is it for us today. Now you should be able to determine the distance between points with the Pythagorean theorem, the distance formula, and we also want to be able to translate a line from one place to another. Have a good night.